Hello friends, today we take up experimental study of photoelectric effect. How experimental study of photoelectric effect was carried out? Let us look at the diagram, circuit diagram. This is experimental setup. Here we have a discharge tube whose anode and cathode are connected through a battery and a milliampere meter, and also cathode and anode were connected to voltmeter for measuring potential difference applied across anode and cathode. Now UV photons, ultraviolet photons of various intensity and same frequency were made incident on cathode. I1 shows intensity I1, frequency nu. I2 shows intensity I2, that is 2 photons with frequency nu. I3 shows intensity I3 with 3 photons and same frequency nu, such that I3 is more than I2 is more than I1. Now photoelectric current versus anode voltage graphs were plotted for various intensities I1, I2, I3 of incident radiation and of same frequency nu. Now observations were recorded for different intensities. I1 nu in table number 1, extreme left, I2 nu, middle table, and I3 nu, extreme right table. Now for various anode voltages, V current was recorded in all the 3 cases for various intensities and for same frequency, and then graphs were plotted. The graphs came out to be as shown. For I1 the lowermost, I2 middle one, and I3 the topmost. Since I3 is more than I2 more than I1, therefore photoelectric current for I3 would be more. And on extreme on the negative x-axis side, all the 3 meet at one point, SP. SP stands for stopping potential. The graphs came out to be as shown. Now this shows that now from this graph, photoelectric current and intensity data was collected. Intensity versus photoelectric current data was collected, and graph was plotted between the two, photoelectric current and intensity, which came out to be a straight line as shown. This graph shows that rate of photoemission depends upon intensity of incident radiation and is independent of frequency of incident radiation. Hence Leonard's law was experimentally verified. Now some questions on it. Question number 8 of assignment 11. If photoelectrons have kinetic energy of 5 electron volt, what will be its stopping potential? So its stopping potential will be minus 5 volt. As you know, what is stopping potential? It is negative anode voltage for which photoelectric current is 0. Now question number 9. In a photoelectric effect experiment, the following graphs were obtained between the photoelectric current and applied voltage. Name the characteristics of the radiation that was kept constant during the experiment. Now it was the frequency that was kept constant during experiment. That is the answer, because on positive x-axis the intensity has different positions, intensity graph has different position, and on negative x-axis all the three graphs meet at one point. So it was the frequency that was kept constant. Now what about second law? How second law was verified, that the velocity of ejected electron is dependent upon frequency of incident radiation and is independent of intensity of incident radiation. Similarly, we recorded three sets of observation between same intensity and different frequency. Now first table here shows intensity I, frequency nu1, intensity I2, frequency nu2, intensity I3, frequency nu3, and observations were recorded. Same experimental setup. Now intensity is kept here in the first case I1, frequency nu1, 2 photons, I, frequency nu2, 2 photon, I, frequency nu3, 2 photons. Now for number of photons is same, is intensity is same. So nu3 is more than nu2 is more than nu1. Now the three sets of observations were recorded for various values of voltage and current, voltage and current, voltage and current, and the graphs were plotted. The graphs came out to be as shown. I nu3 graph top, I nu1 graph bottom, and I nu2 graph middle. Correspondingly, we have sp3, sp2, and sp1. Now these graphs, what these graphs reveal these graphs. From this graph we recorded another data. From these graphs, the stopping potential versus frequency graph, stopping potential versus frequency data was collected from this graph. From these graphs, the stopping potential versus frequency data was collected and graph was plotted between stopping potential and frequency, which was found to be as shown. This graph shows that the velocity of emitted particle depends upon the frequency of incident radiation and is independent of intensity of incident radiation, because Sp is equal to kinetic energy. So Sp we can take as velocity or kinetic energy, V velocity, or Sp stopping potential. Okay, so thus the other law of Leonard was verified experimentally. Now Planck's constant can be determined from the slope of this graph. So Planck's constant from the slope of Sp versus frequency graph was determined. How it was determined? Let us see. Since we know Ev is equal to h into nu minus nu 0, or from here we have He equal to V divided by nu minus nu 0, and is the slope of the graph. Thus Planck's constant can be calculated from this stopping potential versus frequency graph. We can calculate from stopping potential versus frequency graph. We can calculate, we can find the slope. Slope will give h by e, and from h by e equal to v divided by nu minus nu 0, and from here we can calculate h. Now assignment 11 continued. Question number 10. In a photoelectric effect experiment, the following graphs were obtained between the photoelectric current and applied voltage. Name the characteristic of the incident radiation that was kept constant during the experiment. And here you can see frequency was kept constant, intensity was kept constant and frequency was different. You can see on positive x-axis side all the three graphs meet at one point, and on negative x-axis side their stopping potential is different. So it was the intensity that was kept constant. Question number 11. The given graphs show the variation of photoelectric current I with applied voltage V for two different materials and for two different intensities of incident radiation. Identify the pair of curves that correspond to different materials but same intensity of incident radiation. Now here, if intensity is same, here intensity is same, so the pair of graph would be 1 and 3. For intensity is same, material is different. Or here intensity is same, the pair of graph is 2 and 4. So 1 and 3, one pair, 2 and 4, one pair. Okay.